Hello and welcome to TechTribe. I'm Victor, your host for today. As a backend and embedded systems developer, I'm excited to take you on a deep dive into Bitwise operators. In this video, we will explore how they work and see their practical applications in Golang network programming. Let's get started. So you will learn in this video about the first is why Bitwise operators are used, how booleans work, the AND operator with a bonus. We will use the AND operator to find the subnet mask. You'll also learn what is a subnet mask and a lot of concepts in network programming. You also learn about the OR operator with a bonus. You'll learn about the broadcast address and how it is calculated, right? So leave it a like in this video, share with someone that you think this might be helpful with. I have also provided the code and an article in our blog, so you can read later on if you need to. So yeah, let's get started. Bitwise operators, they might seem like a thing of the past from an age when computers had very limited memory, and although they were used more frequently in the past, they remain highly relevant today. These operators work directly on the individual bits of a number, making them powerful tools when you're working close to the hardware or dealing with fields where performance is critical. You'll often encounter then in scenarios such as security and encryption algorithms, compression techniques, network protocols and algorithms, and embedded systems a lot. One thing to remember is that 1 byte occupies 8-bit. One of the main reasons is because back in the days, we needed a way to uniform each piece of information into characters and other symbols. The ASCII table, or American Standard Code for Information Interchange, was the most popular option used as a standard to translate bits into other types of information. All the information needed by the ASCII table could fit in 8 bits, and that was one of the main reasons why 1 byte is the minimum addressable memory space in most systems still today. So, a common example about this fact is that a boolean uses only 1 bit because it can be either 1 or 0, and that needs only 1 bit really. But inside a boolean variable, it takes a whole 1 byte or 8 bits from memory. So 7 bits are wasted memory. With that knowledge, and depending on the software, optimizing that could be crucial for performance. That's one of the examples. Let's learn about the AND operator. And one great way of thinking about these operators is to imagine how light switches work when lighting rooms. Let's imagine a hallway that connects rooms in a house, and each room has a light switch. The state of each light switch can either be on or off. Imagine bitwise operators as rules that you use to control multiple light switches or bits at once. In our Go example, we will use the AND operator to perform a subnet masking, an important operation on network programming. But before that, let's talk about key network concepts we will use in our example. The AND bitwise operators, if either switches are off, the light on the hallway will be off, because the AND operator will only be true if both of the operands are true. But we're talking about network on this video, right? And what is a network? When we're talking about this concept, the idea of network is to simply have at least 2 devices communicating. So that's simply it. Networking is 2 or more devices exchanging data. The internet is the biggest public network of our planet, and it consists of various smaller groups and divisions of networks, and these divisions and these groups, they're called subnets. So subnets exist in various forms. They could be one network inside of an organization. So an organization could have a separate subnet for each department, and even your home network can be a subnet, right? The internet protocol, and it probably is. And the internet protocol is another key concept. It's a set of guidelines that tells devices how to identify themselves and communicate with each other on a network. A key part of IP is the IP address, which is used to recognize each device. Now, let's understand why performing a bitwise AND operation with subnet mask and the IP address will give us the network address. So for the AND operator, we will check which are the common values, right? So if it's both of them, if both of them are true, it will keep true, right? But if either of them are false, it will be false, right? So you get it. The number 192 is will be this number in binary, and the number 255 will be um, equivalent to this binary number, right? And if you perform an AND operation with each one of these, you will get this result. So you will get the first number, or the first portion of the network inside the IP address, right? So that's how it's performed, right? So now that we understand how this process will work out, let's see a practical example on a Go code. Let's get the network address using only the IP address and the subnet mask. So guys, you don't need to worry. All this code will be provided in a repo link down below. So this will be the a Golang code to perform a bitwise operation to get the network address out of the IP address. As you can see, this will be the result, right? You don't get the host. So right here we have a net.ipv4 address. You can import the net package from Golang. And one great thing about the net package is that you also have an IPv4 mask method inside the package, which is awesome. So we convert IP and the subnet mask to 4 byte slices for perform the bitwise operations correctly. So we get the IP, and we will convert to 2 4, so an IP, and we'll have the mask bytes, which will be equal to our subnet mask that we have previously created. And in order to get which is the correct network address, we will perform an AND operation with each of the relatives. So this is the print, and this is the output. This is the AND operator with network examples, guys. Now that you understand how the AND operator works in network programming in Go, let's cover some key real-life examples on how you could use the OR bitwise operator. But before going to our coding example, let's see what is a broadcast and networking. So each network or subnet has a special broadcast address that allows all devices on the network to receive a message. Broadcasts let you send information or services to every device on the network without needing to know each one's IP addresses. So yeah, it's awesome because you can make the processes much easier. And for example, routers in a local network use the broadcast address to send hello messages and to all devices, switches, and other routers. So this helps them stay connected, maintain communication, and discover other devices close to them on the network. So how we calculate a network broadcast address? The first step is we get the IP address. The second step is we then invert the subnet mask address to make a wildcard mask. This is really important. So the wildcard mask is basically we are inversing the subnet mask, right? And the third step is to perform an OR operation, right? So that's how you get the network broadcast address. But how does the OR operator works and how we will use that? So to get the broadcast address, we need to perform a bitwise OR with IP address plus wildcard mask. So the OR operator is pretty straightforward. In here we have a reminder on that. So yeah, I will provide all the link for that. You'll have a blog article in case you want to review that later. But basically, when you have at least one true when comparing bit to bit, the result will be true, right? In order for the result to be false, all the bits compared must be false with OR operator, of course. So right here we have an example about this operation. So 192 with the wild comparing the first octet of the wildcard mask will be 192. Okay, because it's an OR operation, right? You compare this with this with this third one with this third one, this fourth one with this fourth one, right? And yeah, if we get the last one with which is 10, right here I have done like that. So you would have different example with a different number. So if we get the 10 in decimal is equivalent to this number in binary, right? And 255 is this number in binary. If we compare bit to bit, each one. So yeah, all the bits are true, so it will remain 255, right? So that's how the OR operator will work. So how can we calculate the broadcast address in a Go code? Let's see that. So this process is just like before. We are making an IPv4 address here. Then we are making an IPv4 subnet mask, and we are converting the IP and the subnet mask to a 4-byte slices for in order to perform bitwise operations. You have this method inside the IP, right? So we get the mask bytes again. And to calculate the inverse of the subnet mask or the wildcard mask, this is the same as the not operator in other languages. But in Go, you don't really have the not operator, right? So this is how it's done. So we are basically inverting. This is basically a not operation working in this octet in all of these bits. So in decimal, it's 0, binary, decimal, binary, decimal, binary, decimal, binary, right? This will be end up with this value, right? We then calculate the broadcast address using bitwise operator OR. So for each IP bytes, which is this thing, which is basically just converted into 4-byte slices, right? But it's basically this value right here. We get the first value, we then perform an OR operator with this value right here, and we do all of that with each of our octets. And right here I'm printing the result so we can see what happened. And yeah, this will be the result by the end of this operation. You can test inside your machine if you want to, and that's how you get the broadcast address of a device.